Okay, so let's have a go at this. This is a typical exam style question. First of all, I'm going to expand that out. So I've got r cos x cos alpha plus r sine x sine alpha, and that's going to be equivalent to 4 cos x. Sorry, I should have said that's a minus, because when it's a plus and a cos, that becomes a minus, and that will be minus 5 sine x. If you do something silly and forget about that, this will remind you that that should be the same symbol, okay, when that's expanded. Right, then you match these up, so the coses match up, so I get r cos alpha is equivalent to 4, and I've got these matching up, so I'll get r sine alpha equivalent to 5. What I can do is now I can just do that divided by that, so I'll get tan alpha would equal, well, actually I might as well write it out longhand just so that you know where it's coming from. R sine alpha over r cos alpha, which is 5 over 4, will be tan alpha equals 1.25, and if you do tan inverse of 1.25, alpha will be, just going to use my calculator, shift tan inverse 1.25, you should get 0.896, three significant figures. And then to get r, you'll get 4 squared plus 5 squared square rooted. So that will be 16 plus 25 root 20, 30, 41 root. I will just leave it like that. So now this can be put in the form root 41 cos x plus 0.896. Hands up if you got that. Right, excellent. Now, the next question is find the smallest value of x for which that function is equal to 0, which is the same as this equaling to 0. Okay, just to put it out there. So we now need to find out when will that equal to 0. Now what I'm going to do is I'm going to try and shrink this all so it's out of the way, and now I'm going to start this. So if I was to solve that for equal to 0, I will divide by this coefficient, which will go to 0, and then I'm left with, so I'm going to write it all over again so you understand, 41 root cos x plus 0.896 equals 0, divided through by that, so you end up with cos x plus 0.896 equal to 0. Take the cos to the other side, so I'll get x plus 0.896 is equal to cos inverse of 0. So now before we start solving this, you need all the values of when that is equal to 0. So let's just write this down at the moment. And 6. So if I've got my cos graph here, okay. Now you've got two places here where it can equal 0. And just be careful. I'm going to write both of them down so you know what I'm doing. So I'm going to do shift inverse cos of 0, and that's going to give me pi over 2. So that will give me pi over 2, and this one will give me minus pi over 2. Okay, so you could start with writing minus pi over 2, and that's pi over 2. The reason why I'm saying this is because if that's more than pi over 2, when I take it to that side, you can do that. Actually, that's a plus, so that's going to fall out, so it's pointless doing that one, and you'll get the smallest value coming from here. So x would actually equal, that will not work, okay, because it will be negative, you want the positive. So it will be pi over 2 minus 0.896. Let's just have a look at this. Subtract 0.896 and you will get 0.675 rads. If you want to put rads, you can, you don't have to. Okay, how many of you lot got that? Those people who did it in degrees, you just need to multiply it by 57, I think, and you'll get it in degrees. Okay, excellent.